So I've started the recording. Let's start up with our session. The very first topic that we are going to discuss about in today's session is going to be about something called port security. So you might have heard about the concept that port security is kind of a concept that is basically used in order to secure our inside network or our private network, and it's pretty popular in securing layer 2 networks. So I'll just go ahead and share my screen. Perfect. So the concept that we're going to talk about over here is port security. Now, if we talk about port security, we can build up a topology like this by taking just one switch. The switch has a name that is SW1. Okay, and let's assume that there are two legitimate users that are connected with this particular switch, and the users are named as PCA, and there is another user which is PCB. And if this particular PCA has an address that is 192.168.1.1, and PCB, let's say, has an address called 192.168.1.2, the MAC addresses that it has is going to be double A and double B. Cool. Now tell me one thing. If PCA, the switch has recently been started up, okay? If we look at the MAC address table, then MAC table doesn't really has any details about the interface and about the MAC address and about the VLAN information that is connected with. It doesn't have any information, okay? Nothing over here, nothing over here, and nothing over here. This is how the MAC address table looks like as of now. Then PCA is actually trying to send some traffic from PCA itself to PCB. So of course the traffic is going to reach out on this particular interface, and let's say that the name of the interface that is connected to PCA is 0/1 and the other interface is 0/2. So when the traffic will actually reach out to the switch, can I say that in the MAC table of switch 1, switch will kind of make an entry that the interface and the MAC address that it associated, that FA0/1 is connected with a MAC address that says AA. Do you agree this? But in order to get the information about the destination MAC address, which would of course be BBB, it would have to do something called unknown unicast flooding. So it will forward the traffic on all the ports that are currently active, and the PC will reply it back saying that, hey there, I'm having MAC address BBB and I'm connected to port number FA0/2, correct? And then the switch will kind of forward the traffic. Now, as this particular information, switch A has FA0/1 and FA0/2, and one has a user AA, and the other has a user BB. What would happen if there is another user that gets connected, okay, and that particular user is this, and the interface that it's using is FA0/3, let's say, and the but this particular PC is attacker. Okay, this is an attacker, let's say, and the IP address that is basically using is 192.168.1.3, and the MAC address that it's using is CC. So what we really want is, by using port security, you can actually configure security on each and every port that you are like facilitating for the communications on this particular network. So let's say that the PC that the attacker is basically using doesn't get connected with FA0/3, which is kind of a new connection. Let's say that the PC is kind of connected with this particular cable, the FA0/1 itself. And how did that connection happen? The FA0/1 is no longer connected to that particular PCA, but it is connected to the attacker PC. And why so? Because PCA, he kind of removed the cable. So physical security also comes into play over here. If your switch's physical access is locally available to each and every one, as it is exposed to everyone, then anyone can actually plug a cable inside your switch and they can actually access your network information by just connecting on it and send some traffic of their intent. Cool. So we were discussing that how port security would actually work. And over here, port security means that you can actually secure your switches ports. Okay, meaning that you can take control on who should be able to connect with your network, who should be able to connect with the switch that you have in your production environment. Meaning, let's say that there is a network administrator. Let's say that you have 10 users that needs to be connected onto the network, and let's say you have MAC addresses as double A, then you have double B double B, double C, double B double D, and so on to something like 10.10.10.10. Let's say these are the 10 users that needs to be connected. Okay, and now network administrator actually knows that what are the MAC addresses of these particular PCs that needs to be connected. So you can actually connect the first PC with FA0/1, and then FA0/2, and then FA0/3, and so on till FA0/10. Do you understand that? Now, how port security works over here, that whatever PC that you connect onto the switch's interface, the interface actually reminds the IP address of that specific host. Okay? And if anyone else apart from that IP address gets connected on the same interface, then the port will go into something called error disabled mode. Okay, it will go into something called error disabled mode. Now there are multiple ways that this particular MAC address can be remembered. You can actually either enter your MAC address that wants to be configured for a specific interface manually, or your switch port can detect the MAC address that is currently connected with that port, and it can keep that particular MAC address in its memory. Make sense to you? So, and if someone else apart from the MAC address that the interface knows about gets connected with the interface, then the interface is going to go down and then manual intervention will be required in order to turn on that interface. So, just like the scenario that we had over here, if you have PCA and PCB, and let's say PCA is connected with that particular switch port which is FA0/1, but somehow the attacker kind of gets able to connect with the same. Yeah. So do you understand what I'm trying to say about with the meaning of port security? We were discussing that uh, whenever the illegitimate user gets connected with the interface of a switch, it means that the port will go down and manual intervention will be needed in order to turn that port up again. Do you understand the basic meaning of how port security means or what port security means? Perfect. So we'll just go ahead and try to configure this port security thing. Okay. And we'll see how it works in Packet Tracer. So I'll share my other screen with you. Perfect. So we'll go and see the switch over here. And we'll connect that particular switch with two PCs. That's our PCA and that's our PCB. And I'll just connect them with this switch. And let's say the IP address that we use over here is 192.168.1.1, and the other IP address that we use is 192.168.1.2. You get that? And then we'll just kind of, now if I check the MAC address table, show MAC address table. There is no MAC address inside of this particular switch, right? The name of that mode is error disabled mode. And then I'll just try to send traffic from here to here. And then you can see the traffic is going successful. And then we will kind of see the both the MAC addresses that the switch actually knows about. Now, if I just say that there is another PC inside of your network, and let's say this particular PC is an attacker. I'll just name it as attacker, and let's say that the IP address that it's using is 192.168.1.3. Now, what happens is we will kind of detach the cable of FA0/1 from this PCA and we will attach it with the attacker PC. And let's see if the communication works there. So I deleted the cable and I again attached it, which is again using FA0/1 itself, right? So if we kind of fast forward it, and then the MAC address that you actually had prior to this was this. So I'll just try to send it again, and the packet got successfully done. And then if we kind of check it again, then the FA0/1 was connected with a MAC address CV17, which is not the one that it usually knew about. Correct? So both the MAC addresses are different, but the destination MAC address is just same 705D 705D. So that's exactly what the change is. Now, what we want is if this particular user or attacker tries to get connected with switches FA0/1, the port should not really respond over here. And for that, we will configure something called port security. So we'll kind of delete the cable again and we will attach it with the legitimate user, which is this. And then in order to configure the port security, we need to go into that specific interface. So we'll go to conf t on that switch. Okay. And we will say interface FA0/1. And then we will say switch port security. Okay, now it says it's a dynamic port, so we'll need to use another command called switch port mode access, and then we can use switch port security. Okay, so when you use these two commands, your port security will be active there. But then after that, you also need to tell your switch that how it should learn about the MAC addresses. So the command for that would be switch port security MAC address. Okay. And then you can specify there are two ways. You can directly enter the MAC address or you can use another method that is called as sticky. So sticky means that it will choose the current PC's MAC address that it's connected with. So whatever IP address that PC A has, it will take the IP address of that PC and it will trust on that, MAC address, not the IP address. So it will use the MAC address of the PC that it's currently connected with. Do you understand what sticky means? Perfect. So we're going to use the same thing. We will just say sticky and then we will hit enter. And then the third thing that we need to do is we need to configure violation by using the command violation itself. And there are three type of violation. One is protest, the other one is restrict, and then the third one is shutdown. So by using this, and shutdown is the default, I would say, violation mode that is configured on port security. So what does shutdown do? Whenever there is a violation that someone else from the someone else that is having illegitimate MAC address is getting connected with the port, then the first thing that it does is turning off the interface, meaning it will put the interface into error disable mode. Then second action it will take is discard all the packets or all the frames that are coming from that PC because it no longer is legitimate. Okay. And the third action that it will do is let the network administrator know about it by generating a log. Okay, so these are the three actions that shutdown violation mode takes. Then there is another option called restrict. So what happens in restrict is it will let the first action will be that it will let the network administrator know, and second option or second I would say action will be that it will drop all the frames, but it will not put the port into error disabled mode. The port will still be up, but it will just drop the frames that is being received on that specific interface. Okay, and then the the third mode that is says protect. Protect is basically a mode which just drops the frame. It doesn't let the network admin know about it, and it also doesn't put the port into error disable mode. Okay, so that's why shutdown is the most secure mode, and we will configure the same itself over here. So we'll say shutdown, and that is all that you need to do for port security configuration. So you can see that over here, the first thing that we did is configure port security onto the interface by using these two commands, switch port mode access and switch port security. The attacker cannot send traffic on any of this particular mode. Okay, all of these modes will drop the traffic that would be coming from FA0/1 if we are configuring port security on FA0/1. Okay, and we are using shutdown mode over here. So first we enable the port security by using these commands. Then we basically mention that how the MAC address should be learned, and then we specify what action needs to be taken if the MAC address is different than what has been learned. So currently, when I try to send traffic over here from, let's say that you can verify the port security by running a command called show port security. So when you run this show port security, you can actually see over here that the secure port or the port security port is FA0/1. This is actually the port on which port security has been configured. You can see that the maximum MAC addresses that are allowed to be learned is 1. And what is the current MAC address that is learned? It is 0. There is no MAC address that has been learned yet because there is no traffic that has been initiated. And then if there is any, what is the count of the violation? How many times security violation has been breached? And then the action, what's the current action that it will take? Okay, so all the details can be seen over here by using show port security. And then when I kind of forward traffic from PC A to PC B, then you can see that the traffic went successful. And now you can see if we again use this particular command, you would see that the current MAC address has been changed from 0 to 1 now because switches FA0/1 has learned about the MAC address. And if you want to increase the number of MAC address that the switch port should learn, then you can use a command by going into the interface FA0/1. You can say switch port security maximum. You can use this maximum command. And then the amount of IP address that you can have is between 1 to 132. Okay, this is the number of MAC addresses that an interface can learn. But by default, it is just kept to 1. So only one one MAC address would be learned. Okay. However, we're not going to configure it. So we'll keep the information just limited over there, and by using the show port security, you can verify that. So currently the MAC address has been learned. You can see that the current address count is 1 now. Now what I'll do, I'll just change the connection from this to this. You can see that FA0/1 is now connected to the attacker PC. And then when I kind of do the fast forward, you can see that the port is green. Okay, it is not down. However, it is not connected with the same PC anymore, but the port has become up now. But when I try to send traffic from here to here, and as I click, it says failed. And you can notice that the interface as well has become down now. The interface is no longer up, and the PC also has went down. So that exactly is what happened. That port security has been breached, and that's why violation has been taken. So you can verify the same by running show port security command. And when you perform show port security, you can see that the security violation has been breached once. Okay, and if you see show interface FA0/1, you can actually see that the port is now into error disabled mode. Do you understand this? And the traffic will no longer go from source to destination. So if I kind of try to send traffic from here to here, it is not going to work. And even though if I kind of delete this illegitimate connection, and if I connect it again with the legit user, even though the interface is not going to come up. I tried doing fast forward, but it is just red and red there. Why so? Because the interface is in error disabled mode. So how do you get that interface out of error disabled mode? You go into that interface and you say interface FA0/1, and you say shut down, and then you need to bring that interface up by doing no shutdown. So you need to perform shutdown and no shutdown. That's exactly what you need to do. You get that? So that then your traffic will actually start to be forwarded. You see that? The interface is still amber and now it is green. And when I try to send traffic, now it's gonna go successful. So only legit users can send traffic from one PC to other PC. You understand that? So that's what port security means. Okay. Go ahead, do this particular lab and let me know when you're done. Okay, the command that we used, where the first command that we used was switch port mode access, switch port security. Then we use interface. Sorry, then we use switch port security, uh, MAC address sticky, and then we use switch port security violation shutdown. And to verify that, we can use show port security. These are the commands that we actually used. Okay, go ahead, do that particular thing and let me know when you're done. All right, I hope the lab is done by you guys. Then we will move on to our next lab, which is going to be about something called DHCP snooping. Okay, that's the lab that we're going to discuss. Now, I'll kind of again build up a small topology over here. We'll delete all these. We'll also delete this. And we will just bring up our small topology that we often used to have, consisting just one network over here. So I'll take this particular router and a switch and a couple of PCs, right? And then we'll just go ahead and configure our network like this. And the network that we're going to have is 192.168.1.0. So I'll go on the router and configure a DHCP server. Now, what DHCP? So usually how DHCP work is whenever a PC requires that particular DHCP, the IP addresses to be configured by using DHCP, it sends a discovery message. Okay, the screen is already sharing, guys. So we're going to discuss this DHCP server over here, DHCP snooping over here itself. So what DHCP snooping is actually that there might be multiple DHCP servers that are located inside of your organization. So it is possible that a user might use something like, let's say that over here I'm just illustrating it with a specific router, and let's say that this particular router is nothing but an attacker that is using a Kali Linux. Okay. And what can happen is by using some or the other tool on this Kali Linux, a DHCP server can also be set up. Let's say a rogue DHCP server is being set up over here. And then our legit DHCP server is this, which is our R1. Okay. So, what DHCP snooping means is there can be fake DHCP servers like our this router as well. And whenever these PCs require the DHCP addresses to be fetched out, okay, then they are going to share the discovery message on a broadcast address, resulting that this legit router is also going to receive DHCP request or discovery message, and the fake DHCP server is also going to receive the DHCP discovery message, to which it can give the reply. Now, when the reply will be given to the user, it is going to be an offer message, as DHCP uses discover, offer, request, and acknowledgement DORA process, right? So when this offer message is given, that offer message can also be given by this particular fake DHCP server, and it can use, let's say that the IP address this particular fake router is using can be 192.168.1.254. So if this router provides the DHCP config to these PCs, then the gateway will be 254 as well, correct? And what would happen if this particular router is connected with such network, let's say by using another interface that is FA0/4, then whatever traffic needs to go outside of our internet, which is again connected with our R1, will be going through this particular thing. So our traffic will go first to the this router, and then this router is going to forward that traffic onto the original gateway, which is our router, and then the router will send that traffic onto the internet. So usually the scenario over here by using DHCP or rogue DHCP attack is that it's basically using something called man in the middle attack, because the traffic is going to go through this particular person over here. Okay, and that's why we need to configure DHCP snooping in our networks. And what does DHCP snooping do? DHCP snooping denies, or DHCP snooping blocks all the non-verified ports from sending out the offer message of this DHCP, I would say, process. So only verified interfaces or only trusted interfaces like FA0/1 of the switch can forward that particular DHCP offer message to the client. The discovery message, of course, will be sent out to each and everyone on a broadcast address, but the offer can only be given by the legitimate user, by the legitimate DHCP server. Do you understand how DHCP snooping works? Perfect. So that is exactly what we're going to configure. Now I'll just go and say I will configure it on my R1. I'll say no, and then I'll just configure my network. Just look at the lab first. I'll say enable conft and then interface FA0/0, no shutdown, IP address 192.168.1.1 along with the subnet mask, and then I'll say IP DHCP pool original, or let's say A, and say network 192.168.1.0 along with the subnet mask, and default router is 192.168.1.1, correct? Then I'll take the exit, and I'll also configure the this router as well over here. So this is going to be our host name server. Okay, we are going to rename this as server, and then I'll just rename the other router as attacker. So I'll go over here, say no, enable conf hostname attacker. and we'll go to the interface FA0/0 and turn that interface up and configure an IP address 192.168.1.254 space 255.255.255.0. No, DHCP snooping is the best way to solve such kind of issue. And then I would say IP DHCP pool fake and say network 192.168.1.0 along with the subnet mask. And then default 192.168.1.1 and take an exit. Right? Now we have configured DHCP server on both the routers. Let's see by going onto the PC that which one becomes the DHCP server. If the gateway is 1, there you go. It is the original, I would say, gateway, right? That it needs to be. And then I'll go to the second PC. And the address over here is also this. Now, if I shut down this interface, what would happen? I'd say interface FA0/0 and say shutdown. Then you can see that if I go on the PC and again request for the DHCP, then it's gonna be the okay. The issue over here is I didn't configure the correct DHCP. IP DHCP pool fake default is going to be 192.168.1.254. Okay, and end. And now if I kind of try to request for the DHCP server, you see that the gateway is going to be 254. It means that this is the router that is responding to the DHCP now, but we don't want this offer to be received on the PCs. So what do? We will turn on the interface that's over here, and we will again see that only this interface allows it to be. So how do we do that? We basically go and we basically turn on the DHCP snooping by going into enable mode and config mode, and we'll say IP DHCP snooping. Okay, and then we say VLAN 1. Okay, so we turn on this IP DHCP snooping for the VLAN, and then we also can use this for normal audiences as well for all the VLANs. And then after doing that, we go on to the interface that we want to trust. So that is FA0/1, which is the interface connected with the router that is acting as the DHCP server. So we go on to this FA0/1 and then we say that IP DHCP snooping and we say trust. Okay, and then we hit enter. So you see that we basically use this IP DHCP snooping trust, and then by using this, we kind of authorize only FA0/1 in order to forward the traffic. And then you can verify the same by saying show DHCP, now show IP DHCP snooping or show IP DHCP binding. And you can see that as of now 1.2 is there, the expiration, and 1.3 is also there. Okay, so there is no lease expiration that has been configured as of now, but it has the client details that have been associated with it. And you can see then right now if I kind of go ahead and try to get the IP address, the gateway information that is being configured over here, IP DHCP is not working. Yeah, I can see that Apipa is coming up. Strange. I'm just checking what's happening there. IP DHCP snooping VLAN 1, and then I can say interface A0/1, and then say IP DHCP snooping trust. And then I can take an exit, and when I request for the IPs, okay, I'll just go to conft interface FA0/1 shutdown and no shutdown. Then we'll try to see. Okay, the issue might be that my everything is just fine here. So I go on to this show IP DHCP snooping, and it says that snooping has been enabled on FA0/1. And why is it not showing actually? No, it works in Packet Tracer. I've tried it before. Okay, I'll just try to connect another PC and see if DHCP works over here. Desktop and then PC, DHCP. No, it's again not taking the IP. Let's say conf interface FA0/0 shutdown, no shutdown. No, it's not taking them. Okay, I'll kind of do one thing. I'll just try to disable this no IP DHCP snooping and VLAN 1 and take an exit and see if the IPs are coming up now. Yeah, the IPs are coming up. Okay. And then if I just go ahead and conf t ipdhcp snooping, enter, and then say interface fa0/1 ipdhcp snooping trust, take an exit, and then say show ipdhcp bindings, or do show ipdhcp bindings. Yeah, nothing is there. If I go ahead and see if I'm able to get the address, no, it's not working. Okay, can you guys try it over here? The commands are just same. Okay, what you need to do is ipdhcp snooping, then VLAN1 in the config mode, and then go to interface fa0/1 and say ipdhcp snooping trust. Okay, so use these commands and see if your lab is working over there. If, because this is the command that we actually use, and let me know if it works. If it even doesn't work, then that might be an issue with packet tracer. Okay, and if it works, also let me know. Just take 5 to 10 minutes, try this out, and let me know. Yeah. Okay, that might be the issue with I would say packet tracer, that it's not working. But you can take the concept with you that how this actually works over here. Okay, and those were kind of the things. I would say the security thing is snooping, and I would say port security is what we needed to research. Also, let's talk about ACL. Someone has been mentioning again and again that they need to see the introductory part about ACL as well. However, I did cover ACL, but I don't know what's wrong with that. Probably the recording doesn't have the introductory part, as we started the recording quite late. All right, so who was asking for the introductory part about ACL? Okay, got the someone got able to actually configure the DHCP snooping actually. So yeah, the commands are same. It might be the packet tracer that's not letting it work. Okay, so you can try it on your own PCs and see if it works. But you can take the concept with you. Now going ahead with the ACL, there's no difference I would say in those networks. So if we talk about the ACL and how it actually works, I'll just take a normal topology again. Let's say that I'll delete these networks and say we have a router over here and a router over here as well. And then we have a couple of switches that are again connected, and I'll take the same network over here. So let's say that we have these three networks. Perfect. So these are the networks. So we are discussing about ACL. Now access control list uh, is something that actually is used in order to filter traffic from one direction to other direction. Okay. And so as we have this particular network over here, that is router 1 is having 192.168.1.0 network and 3.0 network. Then you can say that the router 2 has 192.168.2.0. I'll just mention it over here, and 192.168.3.0 as well. So I can say that in order to access control list is kind of a mechanism that is used in order to deny the traffic from one direction to other direction. So let's say that if you want a host that says 192.168.1.2, let's say that's an IP address that is configured on a host, you don't want this particular person to communicate with this entire network. So you would deny such kind of traffic by using access control list. Now there are two type of access control lists that we actually use. One is a standard access control list that is ranged from 1 to 99, and there is an extended access control list that is ranged from 100 to 199. Okay, and both of these access control lists can be configured on any router. However, the best design practice says that standard access control list is configured nearest to the destination. Okay, and extended access control list is configured nearest to the source. You get that? That is exactly where the access control list is configured. So, in order to do something that resembles that, this particular PC should not be able to communicate with the entire network, or the entire network that is 192.168 should not be able to configure or reach out to the other network. We will use standard access control list. Okay, and how do you actually do that? I'll just go on to the second router, and we will just configure a network that says interface fa0/0 and say no shutdown, and then say IP address 192.168.3.1 space 255.255.255.0. Then I would say IP DHCP pool B and say network 192.168.2.0 along with the DHCP config and default gateway, and take an exit. Then I would say that go to interface uh, SE2/0 no shutdown IP address 192.168.3.2 space 255.255.255.0. What's the IP address that we configured on the other? Okay, that's 3.1. All right. Interface FA0/0 IP address 192.168.2.1, and then go to interface SE3/0 or 2/0 IP address 192.168.3.2, and then I would say router rep version 2 network 192.168.2.0 and 3.0, and then I would go on R1 and say enable a conf interface SE2/0 no shutdown IP address 192.168.3.1 along with the subnet mask, and then router RIP version 2 and network 192.168 1.0 and 3.0. So after doing this basic configuration, the PCs from both the networks should be able to communicate together. Correct? When I send traffic from here, okay, these PCs do not have the IP, right? Okay. I'll say enable conf no IP DHCP snooping. And then these PCs should get the IPs. There you go. Right, 1.4, 1.3, and 1.2 is here. So these PCs will be able to send traffic from here to here, right? Successful, and the communication will work. Now, I don't really want the 1.2 PC to be able to communicate with the entire network over here. And we will configure a standard access control list over here. However, extended access control list is used in order to block a specific protocol. Like you don't want the communication to be done between the source and destination for a protocol like TCP, for a protocol like UDP, for a protocol like ICMP. So if you want to be specific about the filtering, you can go for extended. Otherwise, to block the communication, you can go for standard. So I'll go ahead and configure the access control list on the destination router as it says. Okay, an access control list is configured, or I would say created, and then ACL is then applied on interface. Okay, and you can apply one ACL per interface per direction. That's kind of the rule that you need to always consider. So we will go on to our R2 and we will create an access control list for denying traffic from 192.168.1.2. Okay. And we will go over here on R2 and we will say that access list 10. So the number can be anything between 1 to 100, and that will become a standard access control list. And then I can specify that do I want to deny the traffic, and then I would say 192.168. Oh, sorry, I can use the entire network ID, or I can say anyone, or I can be specific to a single host. So as we just want to block this single host, which is 192.168.1.2, we will say deny host, and then we will specify 192.168.1.2. Okay, and then I would hit enter over here. And then as we want the other users to be able to communicate, we will also need to specify that access list. We will create a second statement in the same list by using the same number, and we will say permit any. You see that? And then we will kind of take an exit. So when I say show access list, then you can see that there is an access list that has a number 10. But then these 10 and 20 and so on, it will go to 30, 40. This will be the list of statements that you have in that particular access list. An access control list works in a way that if the first statement doesn't get satisfied, then it will go to the second statement and third and fourth and so. And until unless the access control list kind of executes or satisfies the traffic, it will keep on being executed. But if the access control is satisfied on the on the first statement itself, then the execution of ACL will stop there only. It won't go to the other statements now. So what we are saying over here is the first check if the source is coming from 192.168.1.2. If it is so, then deny it. Otherwise, permit anyone. Okay, so that's exactly how we configure ACL, and then we go to conf t and say interface. Where do we need to apply it now? We need to apply it on an FA0/0. And in which direction? As the traffic is coming inside of SA2/0, and then it will go outside of FA0/0 to reach out to this network. We will configure it on FA0/0 on outward direction. So we will go on to that interface and we will say interface FA0/0 and say IP space access hyphen group. And then we would say out. Oh, sorry, we will also use the number of the ACL that we want to use. And then we will say out. And then we will take an exit. And now if you can see that when I'm trying to send packet from this PC to this, it is getting successful because the PC IP address is 1.4. But if I try to send traffic from 1.2 to this PC, then it gets failed. You see that? That is exactly how this thing works. Okay. So that was kind of an introductory part of ACL where we kind of discussed about standard ACL, and then you can check back the other videos where I have covered about extended ACL. So hope that is also taken on the recording, and that is the content that we actually had to discuss today. There are, however, other topics as well, which is about introduction to VPN and all. but I'm gonna share some documents with you because those are all self-study topics that has been mentioned into CCNS curriculum, and Cisco has a lot of self-study material as well. So at the end of the training, that is tomorrow, we will be getting a drive link on which you will get all the, I would say, material and official books that you can refer in order to prepare for your new CCN exam if you're going to do so. Okay, and then our tomorrow's day is going to be about automation. So we will see how automation is coming up, and we will see how automation can be implemented as well. And also, do not forget that we are starting our automation training, our 10 days exclusive automation training, including Python, from 14th of December. So, if you guys would be interested, do let us know about your interest. And as we are running with limited seats, okay, only 30 candidates is what we are looking forward to admit for that particular training so that we can keep the experience smoother over there. And the labs will be done on simulation softwares like GNS, okay, or EVE-NG, where installation and then how you can make your PC communicate with the devices and all will also be there. Okay, the cost for the training is going to be $99, and it's going to be a 10 days training. Yeah, we also have a plan to execute CCNP training as well, but that will not be done as of now, as I'm pretty, I would say, packed with my schedule till January. So once we are done with our automation training, then probably we'll plan for the CCNP. But do look forward for this particular training as it's going to be an interesting one. All right, so that was all that we had to cover today. Thank you so much for joining in, and I'll see you guys tomorrow on the same time. Okay, for in our last session of this particular training. So thank you so much. Take care of yourself. Bye bye.